Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra 2. This one is 6.2b. Okay, so today we're looking at how do I graph polynomials. So we looked at in 6.2a, how do I actually evaluate what a value of a polynomial is at a given value. Okay, that's what we looked at in 6.2a, and now in 6.2b we're actually graphing these and talking about some different types of graphs of polynomials. All right, so here we go. End behaviors of polynomial functions. This is something that you probably have heard of, but it's nothing that you've really maybe seen before in math, is this concept of infinity. Okay, so the behavior of a graph as x approaches positive infinity or this negative infinity here. It's kind of that sideways 8. All right, or I just write it as two circles right next to each other. All right, so as x approaches positive infinity, so that's as x approaches positive infinity. Okay, you can put a positive out there, that's fine. Or as x approaches negative infinity. All right, awesome. So a couple of those things there. So here, like on a graph, as x approaches positive infinity, that's going to be the right side of this graph. That's positive infinity. These are all positive numbers over here, right? So now on this left side of the graph is where we have x approaching negative infinity. And we're going to look at some things here in these graphs and say, hey, what does this graph do when x approaches positive infinity? And what does x do when x approaches negative infinity? And there's two options. When you approach positive infinity, your graph can either keep going down and approach negative and go down to negative infinity, or it can go up and go to positive infinity. All right, so there's two different options that we have there. Okay, and same thing for here. It can either go down this way or it can go up this way. Awesome. So here we go. Recall that a to the n is your leading coefficient. And n is your degree. All right, so we're going to look at these two different things. Leading coefficient and a degree are going to tell us all about the graph of this polynomial. Okay, first we are going to look at my n. So if my degree is even, so like let's say that's x squared or x to the 4th or x to the 12th power, these all look like parabolas. Yes, okay, you guys have seen parabolas, you guys know what they look like. If the degree is even, it's all going to look like a parabola. Okay, and the parabola is not going to be so uniform. They might not be perfectly symmetric like a x squared parabola that we've looked at in Algebra 2 already, like x to the 6th and x to the 8th and different things like that. They might be a little bit different depending on what's going on in there, but they're all going to have that parabola kind of shape. Okay, so here again, if your leading coefficient is positive, that parabola is going to open up. All right, so notice here that both sides go to positive infinity. Positive infinity. All right, if it's negative, you guessed it, it's going to go down towards negative infinity. Both these guys go down towards negative infinity. It is the parabola that opens down. Okay, awesome. Here we go. The next one, if you have if your highest exponent, so if your degree, if your highest exponent is odd, like x to the 3rd, x to the 5th, or x to the 13th power, you are going to end up with what I like to call a snake. All right, so it's not quite a perfect U shape, but this snake might look like, and if your a to the n is positive, so if your leading coefficient is positive, it starts down low, it might snake around, do some things in here, but it's going to end up high. So it goes to negative infinity over here, and it goes to positive infinity over here. Okay, awesome. And the last one, you guys might be able to guess this one. Hey, it's just the opposite way around. It snakes around and then ends down low. So it starts at positive infinity and goes towards negative infinity. Okay, so that's if your leading coefficient is negative. Okay, that's not supposed to make that into a positive. It kind of looks that way, so that's if it's negative. All right, so here we go. It says give the end behaviors of the graphs of the following polynomial. So if I look at this one, if I have negative 5x to the 3rd, I look at that highest exponent that I see. That is odd, so I know that, hey, this is going to be a snake. So this tells me snake. All right, and this 5 is negative, So I know that, hey, this snake is going to kind of look like this right here. So I kind of like to draw myself a little bit of a sketch here. So I have some sort of graph that comes in here like this. I suggest that you draw yourself some sort of a sketch. All right, that's when we know, hey, it looks something like that. We don't know exactly what it does in the middle, but hey, that's what the end behaviors are, right? So now my end behaviors are these. So as x, so that's how we kind of like to write this, as x goes to positive infinity, f of x goes towards, and as x goes to negative infinity, f of x goes towards blank and blank. All right, so I'm going to write that down here for both of these guys, save myself some time in the end. As x goes to positive infinity, f of x goes to blank, and as x goes to negative infinity, f of x goes to blank. All right, so let's go through and see, especially for this first one here, if f of x, negative 5x cubed, as x goes to positive infinity, so that's the right side of my graph, this guy is going down towards negative infinity, so that's why negative infinity goes here. And as x goes to negative infinity, that's the left side of my graph is going up towards positive infinity. All right, awesome. So now if I look at this next one, I notice here that my highest exponent is 4, so that's going to be a parabola. Parabola. All right, that doesn't look like parabola, but it is. And this is a negative, so this parabola is going to open down. Okay, so notice here that, hey, both my sides is the right side of my graph over here is going down towards negative infinity, and my left side of my graph over here is going down towards negative infinity. So they both go towards negative infinity. All right, awesome. So those are just kind of talking about, hey, what does this graph look like, kind of deal there. And then now we're actually going to graph these polynomials. So we're going to find out, hey, what does this graph actually look like? Okay, so it says, hey, make a table of values using the domain, and then plot the points from the table, and then connect these points to make a smooth curve. Check to make your end behaviors, make sure that your graph is correct. Okay, so if I look at this one, if I have my graph, my polynomial, if I have negative x cubed plus x plus 1, I notice here that this has a highest exponent is odd, so this means it's going to be a snake. And I know that this number up here is a negative, so I know that this snake is going to look something like it starts up high, snakes around, and ends down low. Something like that. Okay, so that's what our graph has to look like. So now as I go through and just plug these guys in, f of negative 2, I just plug these guys in. So you can either do it that direct substitution, or you can use that synthetic substitution that we learned about in the last section, is that we can plug these guys in. So I get negative of negative 2 cubed plus negative 2 plus 1. All right, so here we go. If I plug these guys in, I get negative of negative 8 plus negative 2 plus 1. So what? This is going to be negative 8, which is going to be positive 8. So this is going to be positive 8 minus 2 plus 1, which ends up being 7. All right, so f of negative 2 is 7. I'm going to save some time here. I think you guys can go through and do this. If you plug in negative 1, you get 1 out. Okay, so f of negative 1 is 1. F of 0 is actually also 1. So when you plug these guys in, notice here that this first term would turn into 0, this would turn into 0, so 1 would shoot out. And so this is 1, f of 1 is also 1. All right, so, and then f of 2 is negative 5. All right, f of 2 is negative 5. So now I just go through and graph these guys. So I get negative 2, 7, 1, 2, 3, 4, 5, 6, 7. I get negative 1, 1. I get 0, 1. I get 1, 1. And then I get 2, negative 5, which is right there. And then now I notice here, does this kind of look like this sort of graph? Let's see. If I connect these points, I know that, hey, this guy kind of goes below there. This one kind of comes above and down through there. Okay, so you don't have to be perfect on these guys. I don't know if that's exact point or so. That's as far as I know. That's the best guesstimate that I can make, and that's okay. All right, so I know that this guy snakes around. Notice here that it starts up high and ends down low as these guys. All right, so that's my graph. Just plug those points in, -2, -1, 0, 1, and 2, and see what that graph kind of does in the middle of your graph for you. All right, so again, thank you for listening to Mr. Laxton's video on these Algebra 2 notes, and I hope you have a good rest of your day.